together in one folder. The next part is turning points. Okay? The turning points are the points at which a polynomial function switches direction. If the turning point is higher than any nearby point, like right here, okay, that would be called a relative maximum. And usually we'll just abbreviate it. We tend to call those a relative max, okay? But it's relative maximum is the actual term. And then, on the other hand, if the turning point is so lower than the nearby point, it's called a relative, oh, y'all fill in the blank. Relative what? Yeah. Okay? Now, here's the thing. If we talk about maximum and minimum values, they are actually called extrema. But we don't really use that term real often. If I asked you to state the extrema, then I'm asking for the relative max and the relative min. Okay, turning points define where the function is increasing or decreasing. And that's going to be a big part of this next step, okay? So, in this next box, it says, using the calculator, graph the function above. Enter the function in y equals, then hit graph. Okay, so let's plug it in. So, x to the third minus 6x squared plus 7x plus 2. And we're going to graph it. And it gives us some curves, right? Okay, now, what they want us to do, they say use the calc menu to find the minimum and maximum values. And it says move the cursor to the left bound of the turning point, hit enter. Move the cursor to the right point of the bound, hit enter twice. Okay, so here's the weird thing about this. I don't know why they did this when they wrote the program. But let's go ahead and do the max first, and you'll see this. So I'm going to hit second, and I'm going to hit the trace button to get the calculate function. And the first one I want to go to is the maximum. So we're going to go down to number 4 and hit enter. And I always want to start with the left boundary. So I'm going to start with this cursor flashing on the left side of my peak, or my maximum. And then I'm going to trace over to just past it, and I'm going to put my right boundary. And see how I put these little dotted lines here? That shows which measure, or which part it's finding the maximum over. But then it gives me a guess if I hit enter just one time. So I have to hit enter twice. And it's telling me that for this equation, the relative max is going to be at 0.71, 4.30. Okay? Now, let's go back and do the relative min. So, second, calculate. I want to calculate the minimum this time, so I'm going to go for number 3. And I want the left bound first, And I'm going to arrow over and pick a spot on the right side of that minimum. I'm going to hit enter again. So I've got my two lines showing where I'm finding the minimum over. And then enter again because I want to get rid of that guess. And it's telling me that the minimum value is at 3.2. Is that 2.6, Abby?
I don't know who let me get that.
It's a 9.
A 9, okay. And then negative 4.30. Okay. Now, for this next part, we're only really looking at the x values for the increasing and decreasing intervals. So I'm only really worried about x. I'm not going to worry about y. Okay? Now, for this graph, it is increasing, or my y values are going up. Okay, so they start going up at from negative infinity. And they go up until I get to my first relative max. And at 0.71, just before 0.71, the direction changes. Or just at 0.71. So we actually get something kind of interesting, okay? Let me go up here, since it's a smaller group, and I'm lower my top group too. Have I told y'all that? I'll lower my best group. So what's happening is, as this is going up, it's increasing, but the amount it increases slows down, and then right here, it flattens out. That's at the 0.71, right? So it's neither increasing nor decreasing. But then it starts decreasing going down this part until I get to the minimum. And then it flattens out again. Okay? So I'm not including the 0.71. I'm not putting a bracket there because at 0.71 it's flat. Right? It's neither increasing nor decreasing. Okay? But up to 0.71, it's increasing. Then it's going to decrease from 0.71, and how far is it going to decrease? Down to the x value of the minimum, which is 3.29.
Where is it decreasing?
Okay, it's decreasing from 0.71 to 3.29. So between this relative maximum and this relative minimum, see, as I'm going from left to right, it's going down. Whoop, it's going down. But then it flattens out again at that minimum, and guess what? It starts increasing again, doesn't it? It starts going up. So from 3.29, how long does it keep increasing after 3.29 for x? Infinity. So it's increasing from negative infinity to 0.71. At 0.71, we have that one little flat spot for a second. And then it starts decreasing from 0.71 to 3.29. And then it starts increasing again from 3.29 to infinity. So it's going uphill, it climbs the hill, it goes down the hill, and then it starts going back up again. Kind of like on a roller coaster, right? So, okay, now, on these next examples, it asks us to go through and find the domain, the range, the relative max and min, the end behavior, increasing intervals and decreasing intervals. So I'm going to go to one more video because we're at about 11 minutes. I'm going to do one more video with 2 examples of this.